ఇట్లా రికార్డ్ చేస్తుంది ఇట్లా మిస్ అయినా ఇట్లా రెఫరెన్స్ రాగానే క్లాస్ వచ్చి అంటే రికార్డ్ చేస్తుంది రికార్డ్ చేసి యూట్యూబ్లో పెడతారు యూట్యూబ్లో పెడితే మొత్తం ఇట్లా రివైజ్ చేసుకుని మంచిగా ఉంటుంది.
There are so many rules, so many there. Stand up, shift. Can you spread out?
అవన్నీ అవన్నీ చెప్పేసిందా ఏంటిది అవన్నీ అంటే చెప్పింది 3 క్లాసులు అయినాయి కదా అరేసు
Okay, seems like we are again going to waste 5 minutes so that everyone becomes silent.
నేను పెట్టింది కదా నోట్స్ అన్ని పెడతాను అదే చెప్తాను మరి.
I cannot really start till you all are silent. This hasn't happened before with me at Mahindra University, but this class I'm finding it hard to control.
ఏదో అన్లిస్టెడ్ వీడియోలో పెడతారు.
Okay, shall we start your quiz?
ఇది సడన్గా క్విజ్ అంటదంటారా?
Okay, so we can make this back to the next stop. Now we have a quiz. Right there. This one. Add to your lab component or some other part. So it's a pattern at the beginning of every class. I need that I should wait 5 minutes and get maybe silent. So if everyone talks, we'll have a quiz. And then you will talk and let them know. So we are going to start the fundamentals of object-oriented programming. And then also. I told you when we were kids, my parents they used to run this small clinic, and it was in our college, and our clinic was at the ground floor of our first floor was where we used to live. So our parents they were like always accessible to us. They never went out of home, and we used to wait. We were actually jealous why don't they have time so bad go out from 9 o'clock. And eventually I'm watching Pitch Black. Am I audible? Now? It's okay? Okay. So they had this small clinic in a small colony, but their ambitions were bigger and better. And one of the fact that ambitions, I think, like many Indian households want to get a big lavish home in a big city. So my mother, she once visited this Golconda Fort in Hyderabad, and she was like, I want a house which is at least as bigger as this. So anyhow, jokes apart, so they wanted a big house, and daily they used to plan for it. So at around 10 or 11 a.m., my dad will draw out a sheet of paper, and he will start designing their dream home. Here will be our living room. Here will be our dining room. Here will my mother will sit near him and she'll listen to him with intent, and they will go on an hour or 2 hours, see the patient comes in, disturb them. And it will happen daily. Daily you walk into that clinic and that activity was happening. And somehow we found it very amusing, me and my brother. And we found it funny. Because there was no real outcome, it was all in their imagination. So one day as they were doing it, my brother was in the clinic and they were doing it. figure what they are doing and them. They didn't say anything, he came back. I was unaware of what just happened. After some time, I went to them. They were doing the same thing, and I was into anxiety and they thought that we are sort of trying something that we are making the transition for some days. So anyway, 20 years fast forward, my dad actually built that home and they probably moved into that. It's such an investment. Now the bedroom something you need to have some dreams and some plans in action. So maybe we were kids that time, we didn't understand the seriousness of what they were doing. But let's say you want to do anything. Let's say you want to build a bridge. Or let's say you want a metro in a city. You have to start planning. And you can't go out there and start just like that, start building today. So there is a phase and if you plan for 1 hour, that can save you 10 hours of effort. If you plan properly. And that is one thing which is very much needed in programming expansion. And that is what we are going to look at. Maybe tell of the programs that you have written, they don't require much of planning. So let's say small programs, finding factorial of a number or finding and Fibonacci that might need a lot of planning. You can do in case you want it. You want your code to be time and space efficient, you can still plan. But the kind of programs that we are going to talk now are the bigger ones. Let's say you want to build a sprint management system. So some of the 4th-year students are doing it. They don't like TRP, so they are trying to develop a system of their own. If you want a student management system, an identity management system, or let's say you want to build a social networking. So how do you start? Programming it, what are the direct data types that you should use? What are the functions that you should have? Especially, let's say when you go to industry, their projects. So you cannot start working on a project without proper planning. Different people are going to work on different portions of that project. Later, you are going to put it together. And that is where object-oriented programming helps you. It allows you to structure your code in such a way that it is better organized, better designed, as compared to the procedural programming. And I'm pretty sure you have seen some of that before as well, some kind of planning. Let me give you an idea. So let's go to the handout. I hope everyone has this. Okay, so let's say we are building a student management system to start with, and there is some information for every student that we want to keep track of. Let's say name of every student, roll number, and marks in some subject. So physics is something I hate, so I'll use that in the exam. Now, how do you start this kind of data for this? What data types to use? What data structures to use? So one idea is this, as you see here. So there are 3 arrays. One is for roll number, one is for name, and one is for marks. And let's say we have 100 students, so every array is 100 in size. Can you give me a better way of representing the same information? Take some time to think. Now discuss with each other like that. Okay, so the question is, we need this information for 100 students. We need to choose their roll numbers, their names, and the marks in a code. Let's say pupils. Give one way of how store this information. Now, 3 separate tabs where the zero element in each array is the first student, one element in each array is the second student, so on and so forth. Okay, let's work on your knowledge that you have built in C programs language. Let's say it's a C code structure. Person name? Kushi. I'll pick it offline. Okay, structure. Right? You can use that structure here. How many of you have seen structures, heard about them? Can you raise your hands? Okay, so how do you write a structure here? Let's try doing that. So what do? You should have seen this before, I'm pretty sure. This probably would have been somewhere in the middle of your data structures or C course. So you can create a struct student, which can have all these three things. So your roll number, your name, and your marks. And you can keep it double or float only. And this is the structure for one student. And what do I do if we have 100 students? So you see what essentially we have done here. We have created a new data type of our own. Just like you have integers, you have characters, you have double, float, string, we created a new data type which is student. And now you can create variables of type student. Right? How? Simply, just like whatever you do with integer, you can do that with student. You write student s, right? You get a variable of type student, which will have all these three things wrapped together, which is roll number, name, and marks. Right? So that is the power of structure, allows you to wrap different kind of data types together and create something which is bigger. What kind of programs have you written? Yes. Tell me all the programs you have written which use structures. Use it linked list, right? Struct node we created in linked list. So node was a combination of whatever is the element and a pointer, maybe two pointers. Okay, good. Linked lists, right? Which you actually made with node. But linked list can also be a structure. What else? Tree, stack, views. So you are able to do all these things with the help of structures. And you see the power they provided you. So the power is that for abstract data type. You call stacks and queues abstract data types. Why is that the case? What is abstract about them? We'll come to this term again and again in computer science, which is abstraction. Stacks and queues are what abstract data types. Integers, no, they are not called abstract. So what is so abstract about stacks and queues? Let me give you another example of something which is an abstract data type all of you would have worked with, which is a list in Python. Why a list in Python is abstract? You see, when you work with lists in Python, how do you work? You know, if I write L equals to square braces, a list is created. Right? You do L dot append and element is added. Right? What other operations you have? I think you can even push and in the Python list. So there is a list, you know how to create it, you know what operations you can do. But do you know how it is internally implemented in memory? We don't know. And the point is we also don't need to know that. Let's say there's a CA who is using Python for his work. He just needs to know how to work with lists. Internal implementation is of no use to them. Same is the case with stacks and queues. Let's say for some of my application, I want to work with a stack. All I need is a data structure which looks like the classical example of a stack, plates in the mess. Right? So there is this bunch of elements. I can push one on the top and I can poke one from the top. That is a stack. Now it really doesn't matter to how you have implemented it. She could have implemented it with an array, a list, but that doesn't concern me. I should be able to make a stack, push and poke. That's all I know. right? Very much like how you operate on a car. You don't need to be an automobile engineer to drive a car. You know, you move the steering, car will talk. So the same thing is the abstract data type and abstraction here, which is one of fundamental, you can say, properties of object-oriented programming. What are all the details about that? We will see that in details slowly. So abstraction is one. There are some more fundamental principles to object-oriented programming. And your syllabus, you'll see they are called pillars of object-oriented programming, if you have gone through that. And there are just some terms: polymorphism, inheritance, encapsulation. We will see all of them with the help of certain coding examples. So there is this very nice YouTube acronym that I found for it. They call it a PI. This is an acronym if you just want to remember that. So A is for abstraction, P is polymorphism, I inheritance, E encapsulation. You don't need to cram. We will see all these concepts as we move forward. Okay, so now moving on, we will start with one of the most fundamental construct of object-oriented programming, which is a class. So I'm going to live code it. If you want, you can do it in your lab house. And a class, if you will see, it is very much similar to a structure in some ways, and it is different from a structure in some other ways. So we are going to look at that. I'm using the example of a structure because you already know what structures are. So it's easy to understand classes that way. So first, let me take you through an example of a structure. So this is not a part of this course. I'm just showing you. You might have done this earlier itself. Right, so this is how a structure looks like. So here is a structure student. Since you don't have string data type in C, it's a character array of name. You have marks, you have roll numbers. And now this is one hell of a statement which might scare you, but same thing, dynamic memory allocation. You will see doing this in Java is pretty simpler. So any idea what is happening here in this statement? Dynamic. So malloc allocates memory. How much memory? Whatever you need for one student. So for one student, you need 100 bytes for this, assuming each character is 1 byte. Let's say 4 bytes for float, 4 bytes for integers, whatever it is in your system. So that much memory malloc allocates you, and then in the memory and returns you a pointer, which is nothing but the address of that memory, which is S, and then you can happily work with S, right? The marks of S, roll numbers of S. And the point is you can make as many, you can create as many pointers as you want. So you can have a ST, you can even make an array of pointers, so on and so forth. But I hope that it is clear that the moment when you write this struct student, this, there is no memory allocation. It is only a template that when you will be creating a student, it will be having these 3 fields. And here is a place where you actually create it. Okay. Now coming to the idea of a class, you'll see it is very similar. It's almost the same. I'm going to create a new folder. So by the way, all of this code is updated on the shared drive folder, whatever we do it in the class. Okay, so creating a file here, the student management system is the acronym .java. And now we want to have a class student, pretty much like the structure student, which can hold 3 data together. So we're going to create a class student which has 3 data. So one is roll number, another is name, and let's say marks. That's all. And you don't need a semicolon here like structure. Right. So we are done. Now you see how it is different from the codes that we have written so far. Previously, the codes that we have written, they had functions in the class and no data. This time we are doing it the other way around. We have 3 data in this class. We don't have any function as of now. We are going to add functions slowly. But the point is, it's exactly like a template for a student. Each student will be having a roll number, name, and marks. That's all. This class is complete. This file is complete. I'm just going to do an ls here. It shows you what all is there in this folder. Currently, it is your file. And let's compile it and look again. So now you have a class here, which is student.class. Now the next question, can we run this student.class with a Java student? What do you think? So let's try doing that. And we actually get an error. Right? It says that the main method not found. Okay, so just like C, for any Java program to work, it should have a main method. Now the point is, every class doesn't need a main method. As of now, we just created a class student which has 3 types of data. This class is complete in itself. We are going to create more variables of type student. This class doesn't need a main method. So just like structure, the definition for this class is complete. Next is, you want to create variables of the type student that you need to do in a main function, which can be in the same class or in another class. So I'm going to take another class and I'm going to call it client. I'm calling it client because it's going to be at the client side. What does it mean? For somebody who is giving you the student management system, they are going to give you student.class, which will have certain attributes, certain methods. And what client can do, he can create variables of type student and use it the way he or she wants. So this client class have your main method. And this now is going to create a variable of type student. So let's say student S, right? And now we need to allocate memory to it, just like you did with structure. And the syntax for that is this. We'll slowly see what this means. So this new is very much like malloc. It allocates memory to you for one student. And now you can refer to this student with this alphabet S. It can be anything. It can be ST. It can also be a name, whatever you want. It's just a variable name. To be correct with terminologies, now in object-oriented program, you do not call it a data type and a variable. Student is a class, which is a template, and S here is called an object. Right? So let me write here. S is an object of student class. Okay. And now you can start using all the, so these data here, you can call them data members. You can call them attributes. You can call them state of a class, whatever you want. You want to work with this? Similar to structures, you can use a dot operator. S dot roll equals to 1, let's say. S dot name equals to Aditi, let's say. S dot marks equals to 90.8. And then you can print all of this information. Nice. You should remember to use the concatenation operator here and not a comma. Okay. Done. Would you like to correct something here? S dot, right? So inside main, it doesn't know what is role name marks. All of these are associated with the student S. We'll have to write S dot roll number, S dot name, and S dot marks. So you got this client dot class. You run and it shows you roll number, name, and marks. Okay, we'll take a quick 1 minute break here. Let me know if you have any questions so far. Well, once again, repeat it. Again, look at this student like a new data type that you are creating. We call it a class. Once you have created what this data type is, you can go about creating variables of this type and use it. The thing is, this data type, we call it a class and the variables are called objects. So till now, it is exactly same like a structure. We are wrapping data together inside one unit. Now we will see how a class is different from a structure. So a structure usually has only data. But a class, am I audible till the back? The problem is I need to hold. I'm audible, right? Okay. So as we have seen in a class, you can also have functions inside a class, right? Again, if you remember what we have done till now in Java is we had functions inside a class. As of now, main function, and we also created some more functions. So you can have both data and functions in a class. So I'm going to add a function here. So void is the return type, and let's name this function as increment. And what this function can do, any function that you write in a class, it can use all this data. So what it will do, let's say it will take the marks and it will increment it by 10. So now if you look at this class, it has both data and functions. This function, you can call it member function, or you can also call it an interface. Again, we'll see why interface slowly with time. Okay, now how do we use this function? I'll come down here and say s dot increment. Can you predict the output now? So let me just decrease it a bit so that it makes sense. Right, so I hope you can guess what will happen now. You created an object S, initialized its values. The moment you do s dot increment, it goes here and increase the marks. Now be aware that whenever you call this increment function, it is associated with the object S. As an example, if I make one more student here, let's say student T, and it is another object of the same class, having the same fields but different values. What will be the output now? Error. Error. Student. Okay, so let me clarify this here. When you say student S equals to new student, what it does? It allocates some memory here, right? Which is three parts. One is your marks, your roll number and name. And S is a reference to this. When you do student T equals to new student, you have a different memory location, which again has a marks, roll number and name, which are different. And this one is now referred to as T here. So both of these are different. So will the marks of S change now? Marks of t will change because we have called t dot increment and not s dot increment. So this is what a class in object-oriented programming is. What it does is it allows you to better structure codes as compared to procedural programming because you have all the data and the associated function with it at the same place. And this is what the E in Pi stands for. So you see, it is different from your procedural programming. If you see, this is what happens in your procedural programming. You have some data which is all open. You have some function and your data keeps on flowing through the functions randomly. But if you talk about object-oriented programming, you closely associate your data with functions. So this entity that you see here, this data and functions, these are all close together. This can be another object whose data and functions are close together, and we'll slowly see how these functions can talk to each other. So it allows you to better design your codes. That again will slowly start seeing. Yeah, coming back to this code, any questions? Okay, so now one more thing. So those of you worried about why we are not doing object-oriented programming in Python, let me show you it is very similar. We are just, you can say, doing it the hard way, which will help you in the long run. If you do OOPS in Java, you can do it in Python, but I don't think I can guarantee it the other way around. You can take any of the Java code, give it to ChatGPT, ask it to convert it to Python. You will see how similar they are. So let me show you an example. So this is how you can create a class in Python. You see the same class. Looks similar? You have class student, which has 3 data, roll number, name, and marks, and one function add marks. Right? So this class is completed here. You want to use this class in your code? This is an example. Right? So this line over here tells you that from this file student.py, you are going to use this class student. You see, it is very much similar to from pandas import data frame, from numpy import array. So what is happening there? Pandas is a package which has a class data frame that you are using. There is a class array that you are using, so on and so forth. Right? So just wanted to show you a mapping here. So you learn object-oriented programming in one language, you can do it in the other. Okay. So coming back, take a look at this code if you have any questions. After that, we'll solve a few problems and today's session.